So we did one of these last time. Could I let you start this one, see if you remember? It's basically solve the triangle, which means find all the sides, find all the angles. That's what they want you to do. So we have, what do we have? So, angle B. Can you all see that okay? Maybe I can make it a little bigger. Yeah, it'd be better to have more room too. So I'll go ABC. So okay, so there we go. So hopefully you can see that a little better. So there's all the sides and angles. Just a little bigger. There we go. Well, I mean, there's some of the one side, one angle. They want me to find all the sides and all the angles. So where should we start? What do you remember it all last time? What would be the easiest thing to do right off the bat? That other angle, huh? That other third angle, because we know that we have the 90, huh? We have the right angle, the 90, right here. And the 16.1, and every triangle holds 180. Remember that fact? Every triangle holds 180. So if the right angle is using up 90 of the 180 total, that leaves 90 left over. And so that means the other two angles have to make 90. So the last angle, or angle, what is it, A? How do we get angle A? Yeah, subtract either from 180 or 90. Yeah, I'll just do the 90. Because the other two have to make 90. What's that? 73.9. So angle A is 73.9 degrees. Good, so now we have all the angles, have all three angles. And they already gave us one of the sides. So now we just need to find the other two sides. How about we find little a? It doesn't matter what order. You could do either one first. Doesn't matter. So I'll give you a second. So SOHCAHTOA. So we're looking at, really you could do either angle. Yeah, there's a couple ways you could go. It really doesn't matter. I don't know. What do you want to do? Want to just use the original 16.1. You could use the 73.9. Because 73.9 is a great, it's not rounded in any way, so it's exactly 73.9. So it'd be great. You could use, I'm just going to do the 16.1. Anyway, so from his perspective, this side is next to him, so that's the adjacent. This is always, C is always the hypotenuse, and this is the opposite side. So I'm going to use the 16.1, but you could totally use the 73.9 degrees. That one would be great. It's not a rounded number, so it'd be just as good. Anyway, I'm using the 16.1. So that means it would be the opposite and the adjacent that I need, right? Because I'm trying to get little a, get a relationship involving little a in there. So opposite and adjacent, which trig function is that? Tangent, right? So the tangent of the 16.1 degrees is the 33.5 over the little a, right? Opposite over adjacent. Like that. You could totally have done the 73.9 and done what? That would have been tangent of him. Yeah. You could have done tangent of 73.9 degrees is opposite. This would then be the opposite. That would be little a. It'd be the upside down, huh? Like that. That'd be great too. You get the same answer in the end. See how that's the same thing? If you're doing 73.9, that's opposite and that's adjacent, huh? Yeah, just flip some on that. Wendy?
Can we use the 90-degree angle?
As our angle?
Yes.
No. Good question. Yes, why can we not use the 90? Yeah, no, good question. Yeah, we don't use the 90 because that is the hypotenuse side. Good clarification, Wendy. Thanks. Yeah, got to use one or the other, too. All right, so if y'all did that or did the other one, either one, how do I now solve this tangent 16.1 is 33.5 over a? Yeah, got to get a, and so how do I go about doing that, Mr. Austin? Yeah, excellent. Just to go ahead and put this over 1, how whenever we have like something that's not a fraction interacting with a fraction, just put it over 1 so it looks like a fraction, and then diagonal. Getting the hang of that? That's how we always handle that. Cross multiply when we have fraction each side. So little a tangent 16.1 is 1 times 33.5. And the little a is saying I want to be alone. So what do we do to get that little a alone? Divide, huh? Yeah. Divide by the tangent of 16.1 degrees. Like that. Boom. Little a equals. And make sure you're in degree mode. Remember the whole mode thing on the calculator. It's degree or radian. Make sure you're in the right mode. I'm going to check my mode. Yeah, I'm in degrees. Because this is a degree angle, right? They have the degree symbol, so it's certainly degrees. So, all right. So 33.5 divided by tangent of 16.1. I'm getting 116.06 on that for little a. And if you did it the other way, you'd get the same answer as well, using the other angle. Is that good? And then we just have one more side to go. So there's the little a. That's over here. That's the 116.06. But now remember, that's a rounded number, isn't it? Because on my calculator, it's really 116.06, 3, 4, 7, 2, 6, goes on and on. And so that's a rounded number. And why am I bringing that up? So what? It's a rounded number. What does that mean we don't want to do? We don't want to use it to do any other calculation because it's rounded, right? So so we have one more step to go. We've got to find the little c. But you do not want to use a rounded number. You never want to use a rounded number to find another answer. Well, unless you use more accuracy. Are you tracking with me? See, if I'm just going to use, I could use this rounded number if I put on about 2 or 3 more spots, because I need the final answer for C. They want me to find C over here now. That's all I got left to find. They want me to find C accurate to 2 decimal places. So therefore, if I'm going to use a rounded number, I'm going to have to use a rounded number more than 2 places accurate so that I can round the final C correct to 2 places. That makes sense? So either don't use the rounded number. I think that's the easiest answer. Just don't use it. Just don't use the rounded number. Instead, use this number and something else. Use some non-rounded stuff. You don't have to mess with it. But if you really want to use that rounded number, you could. You just got to put a couple more digits on it. I'd throw on the 3, 4 probably, which were the next 2 numbers in my calculator. And then you could use it. That'd be okay. That would make the final, then you would round back the final answer correct to 2 places. So, yeah, watch out for that. I just don't want you to get messed up by that. Okay, yeah, so there's a million ways to go at this point. What do you want to do? We got to find C. I'm gonna not use the rounded number. So I'm just going to use my 16.1 again and my 33.5. So what trig relationship would involve the 16.1 and the 33.5 and my C? Yeah, because that's opposite hypotenuse, that's sine. So I could just say sine of 16.1 degrees is opposite 33.5 over hypotenuse, which is little c, that's opposite over hypotenuse. That way I'm not using a rounded number. I don't have to worry about anything. And we solve. Same thing, right? Put it over 1, cross multiply, diagonal. C times sine of 16.1 degrees is 1 times 33.5. Last step to get C alone. Divide by the sine of 16.1 degrees. Boom. So C equals whatever your calculator says. The calculator always knows best. Let's see, sine of 16.1. I'm getting 120.8. Oh, no, we need 2 places, huh? 120.80. And we're done. Is that good? How are we doing on that? No questions? We're happy? All right, I'm going to move on if you're good. Am I going too quick? Looks like some of you are still copying it down. 120.80. All right. Okay, same kind of thing. There it is. They want you to find all the sides, all the angles again. They call that solving the triangle. Find all the sides and all the angles. Let's go ahead and give that a try. what's different about this one from the other one we just did and the one we did last week? What's that?
Doesn't give us another angle.
Does it give us an angle? Exactly. Does everybody see that? No angles here, huh? No angles at all. So, because that was the first thing we did back here, right? First thing we did on this one was they gave me the 16.1. I knew the 90, so I could find the third angle by subtracting from 90 right away. And then, when we found the sides. So on this one, I don't know this angle. I don't know that angle. I don't really have any immediate way to get them. So what do we do? What'd y'all do? Did you find the third side? You could do the Pythagorean to find the other side, huh? Did you do that? Is that what you did? You could do that. What's that? Yeah, and then you could just square root that and get a number. We could do that. Want to do that now? I mean, it doesn't really matter. There's a lot of ways to go. Let's just do that. How about that? That'd be a good start. A squared plus b. We're still going to need to do something about the angles, and we'll come back to that. But yeah, let's just go ahead and do the Pythag. We could do the Pythag here. A squared plus b squared is c squared, right? So 23.2 squared plus 11.4 squared is c squared. Like that. All right, and then and then we gotta square root that, don't we? So let's see what we get here. 23.2 squared plus 11.4 squared. I'm getting 668.2 is c squared, and then root it. So whatever that is. $25.85. $25.85. Like that. So we got the three sides. Now, how do we get the angles?
I know a little bit. So if you're putting numbers in a calculator and you end up getting a number bigger than the combination of the two sides given, then you know that you got it wrong. You should check your numbers.
Oh, if it's bigger than them added.
Yeah.
You mean, yeah, good point. Yeah, the hypotenuse can never be bigger than those added. That's a good thing to double check. This number plus this number is what, 30 something, right? 34 something, whatever.
Yeah.
Right? If you got a C answer that was bigger than 34, say it was like 40.29, or you hit the buttons on your calculator, get 40.29 or 140 point, I'll just make up a really big one. This is what I see sometimes over the years of teaching math. I've noticed that sometimes when students use calculators, they go blind all of a sudden. Now, what am I saying? They get answers like this, and which there's no way that could be the real answer. That's what Wendy's pointing out. There's no way. Now, why? Why is there no way the real answer could be 140? Imagine if you're walking from point A to point B. And you say, hey, I'm going to walk from point A to point B. There's two ways to go. I could go roundabout, go this way and then that way, or I could just go direct. Right? Which one's got to be shorter?
The direct route.
The direct route. So in other words, this plus this, it's got to be longer. Doesn't it? It can't be shorter than the direct route. So you see how 140 is like, not even 40 is possible, right? These guys add up to be some 30-something. So the hypotenuse way's got to be under 30, doesn't it? Does that make sense? It's always good. See what Wendy was just doing there? That she was being real with things. Things were real in her mind. There weren't just numbers popping off a screen. They were like real life. A, B, I'm walking, I'm moving. See that? The more you can do that with yourself in math, the more it's real for you, you'll catch your small mistakes. It'll be like a net while you walk the tightrope of your exam in a week, right? A lot of times students say, Mr. Tarrant, I get stressed in exams, I just make one small mistake, and I fall to my death. Right? It's because there's no tightrope under them, which means reality. Reality. Try to grow in that. That's the number one skill. Like somebody's going to ask me, cold turkey, just one sentence, 25 years of teaching math, one sentence, what does it mean to be a math person? Or what should people do to become more of a math person if they're having trouble? I would say be real with the math. Be real. Don't let it just be numbers on a page or on a screen. Be real. Think about real positions and real. Math is real. I mean, it's not real, but it's modeling things that are real. So try to make it real. Good. Thank you, Wendy. Anyway, so hopefully you won't push the wrong buttons. So 25 is a reasonable answer, isn't it? That's it's got to be less than 30. Okay, anyway, how do we get the angles now? How do we get those angles? Any ideas?
Can we do like a tangent of like side B?
Okay.
And then
How about we do A, just because I like A, it's down here in the corner. But yeah, same thing. Go ahead. Kevin, right? Kevin? Yeah, Kevin.
So if we did like a tangent of like angle A,
Tangent of angle A. Good.
then it would be like 11.4 over 23.2.
Yeah, because this is opposite, this is adjacent, this is hypotenuse. See what Kevin's saying? He's saying, like, let's just grab angle A. We don't know angle A, no idea. Let's say tangent of A. Remember, he's thinking about SOHCAHTOA, right? I'm sure you all are. SOHCAHTOA. Tangent is opposite over adjacent, right? So opposite over adjacent, so 11.4 over 23.2. Okay, excellent. Now what, Kevin? How do I solve for A? Wait. Let me say something first. You'll probably say something good, and I don't want you to. I want to do something crazy first. Just because I've seen it a lot, and I think it'll hopefully be helpful to you for me to show it and then say don't do this. A lot of math I do is wrong math so that you won't. So here's what I've seen. That's an excellent first step. That's exactly what we need to do. Kevin's right on track. Tangent of A is opposite over adjacent. Now, here's what I've seen over the years. Students will go like this. They'll go, oh, we got to solve for A, right? We're trying to find A. Just divide by the tangent. That's actually wrong. You can't divide by the tangent. Now, why not? Well, because tangent is not multiplied. This right here, this tangent A, that doesn't mean tangent times A. And because it's not times, we can't divide it. Why? How do you know it's not times? Well, because it's a function. It's like f of 3. You remember functions from your algebra days? You know, when you have functions like f of x equals whatever, 3x plus 7, or you have some kind of function, f of x is 2x minus 7 or whatever. Anyway, f of 3. That doesn't mean f times 3, does it? It means 3 plugged into the f function right there and work it out kind of thing, right? Well, that's what sine, cosine, tangent, all the trig functions are. They're functions, which means they're like a toaster. That's always, I want to try to make it physical and real for you. What do you do with a toaster? You put stuff in, stuff comes out. So my main point is it's not multiplication. Remember, it's not multiplication. So when you look at that tangent of A, it's not tangent times A. That A is plugged into the toaster, the tangent toaster, the function. Okay, so why am I saying all that stuff? Because that way you won't make the mistake of dividing. Well, then what do we do? How do we get rid of that tangent if we don't divide? Anybody know? Because we got to get the tangent off there. We're trying to solve for A, right? We do have to do that. What do we do? That's why we learned why the last section was all about inverse functions. The way to get rid of that tangent is do tangent inverse. And whatever you do to one side, you have no choice but do the same to the other, and then those cancel. That's how you get rid of it. Not by dividing tangent, because it's not multiplication. It's tangent inverse. That's why the homework you just finished last night, or whenever you did this last week, was about inverse functions, because we need them today. So that's just building. They just give us what we need, and then we use that tool. So we learned to use the hammer yesterday. Today we're building a wall or something. So we learned tangent inverse. So now that's what gets rid of any trig function, sine, cosine, tangent, is the inverse. So you just do the inverse. They're opposites. They cancel each other out. Now on the other side, it's what? Tangent inverse of 11.4 over 23.2. Just hit the buttons on your calculator. Make sure you're in degree mode. You want a degree answer. So I'll do that with you. So you have the tangent inverse button. Is it one place? So yeah, they just want one place. 10th, one place. So I'm getting 26.0 I'm getting 1/6, so that'll round to 26.2 degrees. So that's how we get rid of sine, cosine, or tangent. The inverse function, that's why we have that whole section on the inverse function. Is that good? So far, so good. I need to find one other angle. In fact, you know what I want to do, guys and gals? Is I think I want to use like one more place of it. I'm going to use 1/6 because I want to use this angle to find B. I have one more angle to find, right, angle B. And remember, whenever you're going to use a rounded number, use a little bit more accuracy so that the other one's accurate. So even though they only want one, on the angles, they only want one decimal place, I'm going to use 2 right now, and then I'll round it back for the final answer in a minute. But I'm going to use it to find B. How do I find angle B right now? Subtract from 90, huh? Same thing we did before here. What was this, 25? So yeah, angle B will be 90 minus that 26.16. What is that? 63.84 degrees. So 63.8. So that one will be 63.8 degrees. The other one is 21. I'll round the other one back finally, 21.2. We would have got, turns out it would have been the same. But sometimes it could make a difference sometimes. There we go. We're done. We found all the sides and all the angles.
Oh, but I want C.
Yeah, C's just 9. Is that good? Do you understand the whole tangent thing? So when we don't have any angles, we just say tangent, or you could have done, tangent was best. Tangent of those two, and then the way to get rid of tangent is tan inverse. Just hit the buttons on your calculator, and then if you're going to use a rounded number, use a little more accuracy, get the other angle. Subtract from 90. Austin.
Are the big letters just the angles?
Angles, yeah. The big letters are always angles. The little letters are always sides. Right. That's just their convention. Good. You want to try one of these? Okay, so here we are in number 4. So find the bearing from O to A. So we're going to get real. This is the last section in chapter 2. They're warming us up, and then they're going to give us some real problems where ships are headed in certain directions, and we're going to do some of that stuff today, some which I always enjoy seeing where does this stuff hit reality. So to do that, we got to first learn the skill of a bearing or a heading. So and the language they use. So a bearing from O to A. This is how they talk in navigation talk. So say you're at point O, and you're headed to point A, and you can tell we're doing that 63-degree angle thing. How do you say that in navigation talk? Well, the way a bearing or a heading is stated is you always start with north or south. I don't know why they did it that way, but that's just what they did. So you always start with north or south. So you say, all right, I'm headed north, and then you give how far off of north you are. Or you say, I'm headed south, and then you give how far off of south you are. So you always start with north or south. So in our case, we're going to have to start with north, because we're headed north. We're not headed south, for sure. We're headed north. So we'll say, okay, our bearing is north. Okay, but then it's not pure north, is it? It's not straight up. If it was just straight up, you'd just say north. But it's not straight up. It's off of north a little bit. There's how much off of north it is, which is what angle?
27 degrees.
Whatever 90 minus 63 is. Do y'all see that? So one more time. Why am I doing it there? Because I started with north. I started with straight up. So if I'm headed north, how many degrees to the right? We'll say some amount of degrees east of north. And what it is, this angle here is going to be 90 degrees minus 63 degrees, which is 27 degrees. North 27 degrees east. That's the bearing. So let me try that again. So that's making some sense. So you have to start with north or south. So we said north, but then we're not pure north. We're not pure north. We're a little bit to the right of north, which means east, doesn't it? How far to the right? Well, whatever 90 minus 63 was 27. So we're north, 27 degrees east. That's our bearing. That's our heading. That's how they say it in the navigation talk. That's the answer they want on that one. Questions on that? Let's try another one. Try number 5 there. So you're going from O. You start at the origin. You're headed to A. They want you to give the bearing. It's going to be something, right? And that's going to either be north or south. You always start with either north or south. Some kind of angle. And then the second one is always east or west. Getting the hang of that? So it's north or south, some kind of angle, east or west. Okay, so it's south. So we're headed south. But not straight south, huh? Not pure south, not only south. South is part of our heading, but not straight south, left of south. West, something west, huh? We're headed south, and then how far west of south? 70. Yeah, I don't have to subtract on this one. They're just handing it to me. It's south, 70 degrees west. Is that making sense? So our bearing, so starting from here, if you head south, but not pure south, 70 to the west of south. That is that actual bearing. It's south, 70 degrees west of south. Yeah, Kevin.
Mr. Herring, just one thing that makes compass bearings easier is that if you're doing a south, the angle will always be your answer angle, and the north will always be a subtraction from 90.
No, that's not true. No, so they could have given me this problem here, Kevin. They could have told me this is 20. Here's O. Here's A. Yeah. So a better way to say it is if they're giving the angle off of the north-south, then that's your angle. You don't need to subtract. Whereas if they're giving you the angle off of the east-west, then you're always going to need to subtract. That's the rule. But you might wonder, well, how do you know we need to subtract or not? Right, because we're always wanting it off of the north-south. We're going north or south and then some amount off of that. So if they, like on number 5 here, if they directly give you the amount off of the north or south, off of the straight up and down, the y-axis, then boom, that's your angle. No need to subtract. But if, like on number 4, they give you the angle off of the x-axis, off of the east-west, then you're going to need to subtract on that. Good? Because they're going to put them in a word problem now, so you're going to have a lot of other stuff to worry about. You got to have that part straight. That's how math always is. It builds, 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 right? So we good with that step of the journey? All right. An object moves in simple harmonic motion described by the equation d equals 7 cosine pi over 2t, where t is measured in seconds and d in inches. Find the following: the maximum displacement, the frequency, the time required for one cycle. Okay, so they're giving us real life here, and they're showing simple harmonic motion of things in the real world. All right, let me simple harmonic motion. So an object moves in simple harmonic motion. That means sine or cosine. You know, sine and cosine are the same thing. Cosine is just a shift, isn't it? So sine, cosine curve, sine or cosine. That's simple harmonic motion. Up and down, up and down, up and down. So, okay. So what does that mean? They give me an equation here. So d equals 7 cosine pi over 2t. There's time, right? Over time. Engines. My father-in-law's engine, worked for Cummins engines for years. You know, the pistons in there. What do they do? People that study engines and mechanical engineers, they're firing up and down, up and down, up and down the pistons inside the engine. They have the timing and all that, and they use sines and cosine curves to time out the firing for the engine. Anyway, the applications are a million of them. So, all right, so there's a function, 7 cosine pi over 2t. T is measured in seconds and d in inches. So T is seconds, D is inches. D stands for displacement, which means distance off of 0. So like if you had, this is a cosine, you know the graph of this thing, right? It's a cosine curve, which means starts high, goes on and on like this. So D is your y-axis, basically, right? Because this is where y sits, huh? You with me? That's where y sits. So D is just what they're calling y. It's just a name. They want to call it Joe now, whatever. They're calling it D for displacement. Well, there is a significance that it means distance off of 0. So back with the ball on the spring, if I had a spring and a ball sitting on the end of a spring attached to a wall, and I pulled down that ball and let it go, bong, 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 up and down it went, this would be D equals 0, its normal position. The ball would bounce down to a lowest point. It would bounce up to a highest point, wouldn't it? And kind of go between those. That would be maximum displacement. That would be the top up here and the bottom down there. For any object going up and down, we have its highest point, its lowest point, its max displacement, lowest displacement. Yeah?
Is displacement always going to be positive?
Displacement can be positive and negative, notice. Yeah, right, because this could be negative there. Yeah, so displacement is positive and negative, above the middle and below the middle. Same thing for a piston firing in an engine, right? When the spark plug fires, above and below the middle. All right, so what do they want from me? Find maximum displacement. Meaning, what's the top of the curve? This is max. What's the highest point that graph's going to reach? 7, huh? We already know the app. We had that section on graphing, sines and cosines. 7. We just write it down. Nothing to do there. If you know, the amplitude, the number in the front, is the top of the graph, huh? So that this graph's going to go up to 7, down to -7. Remember, that's what that number in the front of a sine or cosine curve represents. Highest point, lowest point. Okay, next question. How many cycles per second? And then C, time required for one cycle. Let's jump to C first, and then B will be easy at that point. Let's jump down and do C. Question C. Look at question C with me for 1 second. Time for one cycle. Now, what do we mean, one cycle? One cycle. Well, we mean starts here, goes down, goes back up. That's one cycle. From there to there. That's one cycle, isn't it? And then it just does that again, right? U-shape, 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 U-shape. Forever, right? The piston just keeps up and down firing, right? So that's one cycle. This is the time axis. So in real life, you often make the x-axis time. That's the most typical thing they do in real life with trigonometry. Is the y-axis is the movement of the object up and down. The x-axis is over time. So over time. So again, the question. The time for one cycle. What is that? What are they really asking? Have we done that before? Period. Exactly. Do you see that? That's just fancy language to say, tell me the period, isn't it? The time for one cycle is period. Very good. I'm glad that many of you grabbed hold of that. That's what period is. Period is how long one cycle is, isn't it? So that's period. And we have a formula for period. Anybody remember? 2 pi over b. Very good. You can put on your 3x5 card for the exam in a week. 2 pi over b. Good. What's the b? Good, yeah, because this is the A, this is the B. Yeah, exactly. B is the number next to the X, or in this case, the T, the variable they're using, right? So then this is going to be what? 2 pi over 2. 2 pi over 2. All right, and then what do you do with that? You grab, remember when you had a fraction on the bottom? You flip it up, and dividing is upside down multiplying. Remember that kind of thing, right? Dividing by pi over 2 is multiplying by 2 over pi. Remember that? So we just flip that there. Like that. And then pi's are going to cross cancel, aren't they? So it's just 4. 4 what? Whenever you get real, you got to continue to be real. In my physics class, when I had my first physics teacher, if we'd ever gave an answer in physics like 4, Mr. Grimes would go, 4 what, Heron? Is that 4 what? 4 dogs in the kennel? What is that for? 4 what? 4 seconds. Good. We're talking about time here, huh? That's 4 seconds. The time, remember, time is measured in seconds. 4 seconds. So that's 4 seconds for one cycle. So this is time 0. This is time 4. It's 4 seconds to complete one cycle. Where the thing that's going up and down starts up, goes down, comes back up. That's one full cycle for the object, right? If it's a piston in an engine, it's at the highest point, goes down, comes back up. That's one cycle in 4 seconds. Every 4 seconds, it goes down and up, down and up, down and up, every 4 seconds. Okay, now that's the answer to part C for, oh yeah, they even put the units there for me. That's nice. 4 seconds. Now, let's go back. Think with me. Let's answer question B. The frequency. And notice they give me the units. I survived physics because of units. Before physics, I used to kind of hate units. They used to bug me when they wanted meters or kilometers or inches or seconds. It used to bug me and think it seemed like it made the problem worse. But when I got to physics and I read all these crazy word problems and often had no idea what in the world I was supposed to do, I started noticing that if I just paid attention to the units that they wanted, that a lot of times I could figure out what to do just by kind of lining up the units. So look at the units. They're saying frequency, and I'm not sure what that means. Maybe you're not sure what that means. But look at those units. Cycles per second. Cycles per second. Think with me. When we say this is 4 seconds, that's the answer C. Remember I said it was related to answer C. That's why I did C first, then B will be easy. Look at answer C. That's the time, the seconds, for one cycle. So it's 4 seconds for one cycle. You don't have to write that in, but that's what it means, right? It's 4 seconds to complete one cycle. In other words, you could say you don't need the 4 over 1's just 4, right? It's 4 seconds per cycle. Right? It takes 4 seconds to do a cycle. It's 4 seconds per cycle. So what? Well, they want cycles. Now they want cycles per second. This is seconds per cycle. Answer C, the 4, is 4 seconds per cycle. And in B, they want cycles per second. What do we do? Flip it. 1/4. Done. See how the units are just upside down? Frequency is upside down a period. And I'll write that out for you formally. So somewhere I kind of like out of room. I'm going to have to erase something. I'm going to come up here. Yeah. And so let me write that down. So frequency, which is what they want in part B, is upside down of period. They're just upside down of each other. So therefore it's what? Not 2 pi over B, but B over 2 pi. It's just the upside down formula, B over 2 pi. Upside down of the period formula. You can tell by the units. Cycles per second versus seconds per cycle is period. And we're done. So in other words, what does that 1/4 mean? It does 1/4 of a cycle every second. And that makes sense. Look, if it takes 4 seconds to finish the whole cycle, then right here, right here, right here, this is come on. This is 1 second, 2 seconds, 3 seconds, 4 seconds. Yeah, after 1 second, it's done a quarter of its cycle, hasn't it? Right? It's gone from high to 0. Then it'll go from 0 to bottom, then from bottom back to 0, then from 0 up to top. Right? So in 1 second, it's done a 1/4 of a cycle. A 1/4 of a cycle per second. Making sense? So this is all the real life stuff we want to use when this is where trig is used. Things like this. All right, let's move on. Number 8, they want me to find x. Kind of a weird, so just throwing weird triangle situations at us right now. Weird triangle scenarios. So what are we gonna do with that? So figure out something you can do with that.
X is the whole thing.
Yeah, X is the whole thing. That's what's weird, huh? X is like the whole thing there. Let me ask you this. Is the whole triangle a right triangle? No. What am I talking about? I'm talking about this entire thing. Forget about the middle. Just the whole triangle is not a right triangle because the whole triangle doesn't have a right angle. The right angle is somewhere in the middle of the whole triangle. So you see the issue? I can't really deal with the whole triangle at once because the whole triangle is not a right triangle. So I have to do parts. So let's do this one right here. Let's just take this one right here. Can I find, let's call this, I don't know, Y or something. Can I find that Y right there? First off, I want to do this in pieces. Can you find that Y using some trig relation? So just forget about the bottom stuff. Pretend it's not even there. And just look at that top little right triangle. That is a right triangle, right? It's got a 90-degree angle. See if you can use some trig relationship there to find Y. Using the 37-degree angle, thinking about SOHCAHTOA. So what trig relationship would involve that? Let me give you just, rather than me, I'm tempted just to... Well, so what trig relationship involves the 37-degree angle, the Y, and the 500? Tangent, yeah, because this is the opposite side. This is the adjacent, and this is the hypotenuse, right? From the 37-degree angle. So it's opposite and adjacent. That's tangent against them. It's often tangent, huh? So there's tangent. So yeah, that's tangent. So I'll just do it over here. So the tangent of 37 degrees is the opposite, which is the Y, over the adjacent, which is the 500. And so we can solve that for Y. Right, we'll do the cross multiply thing again. So put this over 1, diagonal, diagonal. 500, tangent 37 degrees is 1 times Y. And so what is that? 500, tangent 37. I'm getting 376. 376 point, I don't know. You know what, I'm still, yeah, let me give you this hint, this help. I'm still in the middle of the problem, right? I'm not done yet. So use a lot of decimal places while you're still in the middle, you know, until you get to the end. So I'm going to use like 3 7s for Y. So 376.777. So that's Y, that's that length. Good so far? And now you probably know what I'm going to do. I'm going to come down here and try to find the other part. Call it Z or whatever you want to call it. Bless you. Try to find that Z there. So, and do some trig relationship. See how the 500 is also, it's the top of the bottom triangle, isn't it? So we can do another trig thing. This would be the opposite, and this is still the adjacent. So it's tangent again, isn't it? Y'all see that? So it's going to be tangent of 28 degrees is opposite Z over 500. And once I find Z, then I can just add the Y and the Z, and they make up the whole X, don't they? So put this over 1, go diagonal, diagonal. 500 tangent 28 degrees is 1 times Z. Z is whatever it is. $265 point. I'll just use a lot. I'm going to go 8547. You know, I'm just using a bunch of decimals. just to be sure, because again, these are still, I'm still in the middle of the problem. And now the final answer, x will equal y added to z, huh? I'm getting 642. Oh, they just said whole number.
Yeah.
So I'm really overkilling it.
Not around to the end.
Till the end, right, which is what we're doing. We're basically, they're saying the same thing I'm saying. Use a lot of accuracy till the end. 643. And there we go. Does that make sense how we did that? So it's kind of a double trig thing. Questions I can answer? All right, if you're so, yeah. Let me let you try rather than me just jump in there. So any thoughts? It's going to be a little more tricky. Do you see the main part of the difficulty is that x is not really the whole side, is it? At least not of a right triangle. Do you see what I mean? You're saying, well, you might be thinking, well, x is, he's the side of that triangle. True, but that's not a right triangle. The whole thing's a right triangle, but that little red one I just drew in there is not a right, doesn't have a 90-degree angle, huh? So I can't really directly go after that little triangle because he doesn't, all the SOHCAHTOA stuff that we use, that has to have a right triangle, doesn't it? It all comes from a right triangle. So you can only use SOHCAHTOA with a right triangle. So what am I going to do then?
Cosine of 33 degrees.
And what would, okay, don't write this down. Let's just play around for a minute. So Kevin, what would I do with cosine of 33 degrees?
Use the 210 and then find the hypotenuse for the whole triangle.
Okay, so tell me exactly what to do.
Okay, so you do 210
Uh-huh.
divided by side y,
Divided by what's that?
like side y or
Where is y? Where do you want me to put y?
the hypotenuse.
This hypotenuse here?
No, the one.
This one here?
The whole triangle.
Okay. Gotcha. So, okay. 210. Oh, over here equals 210 over y over here, you mean?
Yeah.
Like that cosine of 33 is 210 over y. Yeah, that would work, huh? That's true. And then you could get y. And then where would we go from there? Say we had y is 118. I'll just make up a number. What would you then do?
I'd have to find the cosine of the 68 next.
Okay.
Find that other side.
To find this right here?
To find the other side of the big.
Oh, to find this? Call it z, this one?
Yeah.
Okay. So then what if you had z as 86? Let's make up numbers. Then what would you do?
Then you would do cosine of 33 for the small triangle, or for that smaller triangle.
What's that?
Would you do cosine of 33 for that smaller triangle with the 86 and 118?
The small triangle is not a right triangle. So we can't do any of the SOHCAHTOA stuff in there. Yeah, does everybody see that? So Kevin was on a good track there. As far as he's totally right with the cosine of this angle, we could find this side. Then we could do this triangle, find that side. And so it's important to know why that road, which looks good for a while, actually ends up as a dead-end street. Do you see it? Because even if we had these two sides, we can't do like sine or cosine or tangent 33 for this triangle. So that's what I was saying. Did everybody understand that? Let me draw this in again. Make sure you're hearing me on this. This is really important. This is the crux to the difficulty. And when you realize it, it'll help you to go the right way instead of a dead-end straight. That is not a right triangle. The red one is not is not a right triangle, is it? There's not a 90-degree angle anywhere in that red triangle, which means you can't do any of the SOHCAHTOA stuff. All of the SOHCAHTOA stuff, sine is opposite over hypotenuse, tangent, all that depends upon you being in a right triangle. I don't know if that's been clear to you up to now, but let me say it as clearly as I can. That stuff is only true if you're inside of a right triangle. This is not a right triangle. So we really don't want to try to get parts of this thing because he's not a right triangle and we're just not going to get us anywhere. So that's important to learn what won't work. Those were some good steps. Let's think instead about the whole triangle. Comment?
You just said the whole triangle.
Do what's that?
We had like the whole triangle where the only angles we have is 90 and 30.
Right, yeah, look at the whole triangle. Right, that's what we need to do. We need to think about the whole triangle because the whole triangle is a right triangle. Has the 90, right? Good. And so does the little one. The little one on the left, I mean. This one. This guy is also a 90. Those are the two you want to work with because those are both right triangles. Everybody tracking with me? The whole thing's a right triangle and the left triangle is a right triangle. The right one is not. So we don't want to directly deal with him because we can't do anything with him. So how about the one on the left? Can we find this little part here? Y? First off, could we do that? How would we find that? Let me give a game plan. If we can find that, and then if we can find the whole thing, from here to here, call it Z, and that's the bottom of the whole triangle, which is a right triangle as well. And we get Y and Z, we can do what with them to find X? Subtract them, right? That's the game plan. Make sense? So you see how all of my thoughts are work with the little triangle on the left because he's a right triangle, and work with the entire triangle because he also is a right triangle. The one on the right is not a right triangle. We don't want to directly work with him. We can't. Okay, so let's find Y first off. How are you going to find Y? Using your 68-degree angle, your 210, and your Y. So SOHCAHTOA, which trig relationship? Yeah, if in doubt, tangent, right? It's almost always tangent because this is opposite and this is adjacent from the 68. So the tangent of 68 is opposite to 10 over Y, right? Opposite over adjacent in a right triangle. So solve for Y there. Put that over 1, cross multiply, you know the drill. Diagonal, diagonal. Y tan 68 degrees is 1 times 210. Last step to get Y alone. Whoops. This is 210. Last step is to divide by the tangent of 68. So what is that? I'm getting 84.845. Again, I'm going to use a lot of decimals because I'm still in the middle of the problem. 84.8455. So there's Y. And now I want to try to do the same sort of thing to get Z and then subtract them. The difference will be X. So how am I going to get Z now? What's a relationship? Yeah, so tan of 33 degrees is opposite to 10 over adjacent, which would be the whole Z. Everybody see that for the entire triangle? Let's see what I'm doing there. Tangent 33 is opposite over the adjacent for the whole triangle. So put this over 1, diagonal, diagonal. Z tangent 33 is 1 times 210. And then divide by the tangent 33. Boom. Z equals 210 divided by Tangent 33. I'm getting 323.37. And then I just take the answer from Z, the answer from Y, and I subtract them. Am I racing ahead of you here? So all of Z minus Y will be X. Huh? So I'll scribble that in over here. So then X will be Z minus Y. X equals Z. 323.37 minus Y. 84.8455. And I'm getting 238. Oh, they want a whole number. I get 238.5, so that'd round to 239 for X. 239. We good? Give you just a second on that.
Does the problem stop once we find X?
Yeah, that's all they want, X. All right, I don't know if you can read all this. Let me just tell you the most important facts. It basically says the tower is 5,280 feet. That's exactly 1 mile. Oh, wait, no, that's not. No, that's not. No, that's not right. Sorry. It's from a point on level ground, from the base of the tower, the angle. Okay. 5,280 feet away, so 1 mile away, the angle of elevation to the top is 21 degrees. Yeah, that's what they're saying. Find the height. So that's the only important fact you need out of all those words. So it's from 5,280 feet away. Its angle of elevation is 21 to the top. Let me show you what that means. That means they got some tower. Here's the tower. My tower is going to be just a straight line. And then if you go far away from it, like far away, so that this is 5,200, sorry, my 8's looking a little funny there, 5,280 feet away, that the angle up to that is 21 degrees. So here's the top of the tower, like that. That's what they're saying, and they want me to find how tall is the tower. Call this, X. How tall is the tower? Now, do y'all see how I came up with that? Have you heard of the idea of an angle of elevation before? So that means from flat, going up. It's how far up from flat until you can see the top of the thing. It's called the angle of elevation. They have, in the olden days, they had hand tools that will measure that. Now they have lasers and things that you point at the base and it tells you the angle at the top, So that's an angle of elevation from flat, so looking to the top of that tower. So this is the ground down here. And 21 degrees is the angle elevated from flat up to aim at the top. So that means if you walked away from this tower 1 mile away, and you have this laser nowadays a laser tool that went up to you're aiming at the very top of the tower, then you found that angle, or the laser would just tell you the angle. That angle is 21 degrees to the top. So can we use that to find X, the height of the tower? This is a right triangle, assuming that's not the Leaning Tower of Pisa, right? That's a straight up and down tower. So therefore we got a right angle to the ground. So it is a right triangle, so we can use all the SOHCAHTOA stuff. So what trig relationship is it? Our favorite. Tangent. It's like all day tangent here, it seems like. Tangent of 21 degrees is opposite X over adjacent, right? This is opposite and adjacent. Fit 280, solve for X, same thing, right? Put this over 1, diagonal. And then you get 5,280 tangent 21 degrees is 1 times x. So x equals whatever that is. I'm getting 2026.8. I don't know how far they want me to. Oh, nearest foot. So we'd say 2027. 2,027 feet tall. Good? I'm going to move on. Okay, so number 11. Basically, the same kind of thing. They want me to find D, the distance at the bottom of that triangle. It's a right triangle. So, how are we going to do it? Any thoughts? Yeah,
Isn't it because,
John, right?
yeah, isn't it because that it's 90 degrees and already gives us the first angle at 32? I'm guessing that's 90 degrees as well. Can't
Yeah.
you subtract 90 degrees from 32 degrees?
Very good, very good. Yeah, this has got to be 90 here because this is straight up and down, that's straight sideways, huh? So that's got to be 90 up there. So take 90 minus 32, exactly. So 90 minus 32, what's that, 58? So this will be 58 degrees right there. Good, now we have an angle inside the triangle. And then what would we do from there? It's a right triangle.
Tangent.
It's tangent again, isn't it? It's always tangent. Tangent 58 is opposite. This would be the opposite side. This is the adjacent, so that'd be D over 1,000. I'm going to go dot, 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 and move on to another problem. Good there? Just had to find that angle inside, and then it's the same from there. Is that all right? All right. I'm going to flex. Okay, so they want me to find that little question mark up there. This is the X, or whatever you want to call it, that they want me to find is how, whatever, that hot air balloon moves. So how am I going to find it? Again, where it's kind of like those other two where we got a couple of triangles inside of each other and you're trying to work everything out. So, yeah. Any ideas? Kevin, right?
Mm-hmm.
Kevin, no?
No, Damon.
Damon. Yes, Kevin's there. Sorry. Damon, what do you think?
And we do the same as we do with the other one, and we think of it as a whole triangle.
Yeah, I like it. Yeah, maybe I'll draw it out if it helps. Yeah, basically you got the whole triangle, which would be the 31.4, right? And that's, yeah, this is the 127. So the whole thing, call the whole thing, I don't know, Z or whatever, and then call just this part Y, right? And then we're just going to find Z, find Y, subtract them, you got X. Right? Call this Z, so the whole triangle, that's Z. And then you got the, I assume, Damon, this is what you meant. And then the little triangle, 16.6, this is Y and still 127. Right? Everybody see that? You can find Z from the whole triangle and Y from the little, yeah.
So for the 31.4 degrees, is that for both? Is that
Yeah, yeah, good question, John. That's for both. Yeah, that 31, that arc they're showing there is saying that the 31.4 is for both. It's the whole thing. Exactly right. Yeah. So 31.4 is the whole angle for the entire big triangle. So if you look at the entire big triangle, right, going straight up here, all the way down and all the way over, that angle's 30. That's what I've drawn here, huh? That's the 31.4. The whole thing is Z. The bottom is 127. So you could find Z from that, and then the little triangle right here, you can find Y, and then you can see that Z is the whole thing. Take away Y, that'll be X, right? X will be Z. Take away Y. Can I go dot, dot, dot and move on? See how it's very similar to those other ones? So I'll move on. A boat leaves the entrance to a harbor and travels 175 miles on a bearing north 53 degrees east. We're going to have to draw that and be clear what that is. How many miles north and how many miles east from the harbor has the boat traveled? Yes, let me just write that out. So number 13, the boat goes 175 miles north 53 east. 175 miles north 53 degrees east. Yep. All right. So basically, we got to draw that and just find out how far it actually moves in each of the directions. So let's start by drawing that. So I'd encourage you to just draw an actual axis system. The boat will start out at the origin, just makes it easy. And then we want to draw the boat headed north 53 degrees east. Can you do that first off? See if you can do that. Figure out exactly where that is. Give you a second. See how that bearing stuff was working for you. Okay, so I'll jump in. So this is north, south, east, and west, right? North, south, east, and west. You're a little rusty on that. Just put it on your 3x5 card. So we're headed north, but not straight. You'd always, whatever you start with that in your diagram. So north is the first statement they made. So north, but not pure north. 53 degrees to the east of that. That's to the right, huh? So that would mean that it's 53 degrees east. So this is actually where we're heading. This is where we'll end up. Call it point A. Start from origin, go to A, or just how about start and end? Whatever you want to call it. It doesn't matter. We start here, end here. Is that making sense first off? That general picture. So it's north, but it's not straight north. It's 53 degrees off of north to the east of north, to the right of north. So here is our actual trip that we're taking, our actual bearing, our heading. So for that, now, okay, great. So what do they want? They want to know for that trip how far east. Did the boat actually go? How far east did it actually go, and how far north did it actually go? So I'm gonna draw a triangle, huh? How far east? Straight east, and how far straight north? That implies a right triangle. How far straight east, and how far straight north? Because we headed off sort of diagonally, but that means we covered some eastern distance and we covered some northern distance, didn't we? We went northeast. So how far to the right did we go? And how far up did we go? We went right and up. How far right did we go? How far up did we go? How far east? How far north? That's what they're asking. All right. Am I good? Probably that's the hardest part. I think once you got the triangle, you all can do the trig from there. What would I do first from there? Austin.
Question about that.
Yeah.
The angle. How do you know if it's coming from the north or if it's coming from the east?
Yeah, it's whatever one comes first is where you start. So it says north first, so I've got to start with north and come off of north. Yeah, so come off of north towards the east. Yeah, so whatever comes first is always your starter. Good. So then, you know what to do next, right? How are we gonna, excuse me? How are we gonna find this angle here? 90 minus, right? Yeah. So 90 minus 53 is, was it 37? So this one is 37 degrees. And so then we take that angle and we do our little trig stuff, right? Wait, do we know any? Oh, 175. This is 175. I should put that down. That's how far we went northeast. Right, our purple line there is 175 miles, is what they're saying. We went 175 miles northeast, or north, 53 degrees east. So we use that to find the east and the north. So we can do that. So first off, for the east, move it over here. So what trig relationship is going to involve east and 175 and the 37 degrees? It's not tangent this time. So right, so Katoa, this is the adjacent side, this is the opposite side, this is the hypotenuse, right? So it's adjacent and hypotenuse, for the east anyway. It's cosine, huh? So cosine of 37 degrees is adjacent to the east over the hypotenuse, 175. So we can solve for the east. Put this over 1, diagonal, diagonal. 175. Cosine 37 degrees is 1 times E, so E is the eastern trip, 175. Cosine 37. 139.8. I don't know how far they want me to round here.
10.
Okay, so that's what it is. 139.8. We got the east, so it went that many miles east. And now for the north. What trig relationship am I going to use for the northern part to find in? So yeah, sine, huh? Because that's going to be opposite in hypotenuse, isn't it? That's sine. So the sine of 37 degrees is opposite, which is north, over hypotenuse 175. Is that good? So you want to solve that for n. Let's put this over 1, diagonal, diagonal. 175 sine of 37 is 1 times n. And I'm getting 105.3. 105.3 miles north. So we found out how far east and how far north we went in that northeastern trip. Good, we got 2 more, so I want to move on. Is that okay with that one? It's all about drawing that picture, huh? That's over the years, that's what I've noticed with hard people is the picture. Yeah.
Now how come for sine we don't use 53 degrees?
Sine 53. So I'm dealing with this triangle right here.
Oh, okay.
Yeah, so I'm just using the angles inside that triangle.
Okay.
Yeah, good question. Is everybody good with that picture? So north, but 53 to the east and north. Let's try another. Directly to the south. The second ranger, 6 miles east of the first ranger, also sights the fire. The bearing from the second ranger to the fire is south 33 west. How far is the first ranger from the fire? Yeah, that's confusing. Okay, so let me try to summarize those words and write them larger for you. So, forest ranger sights a fire directly south. Okay, ranger sees a fire directly south. Second ranger, 6 miles east of the first ranger. Second ranger, 6 miles east of first ranger. Also, what does he do? Also sights the fire. Also sees the fire. The bearing from the second ranger. So the bearing from the second ranger to the fire. Second ranger fire is south, 33 degrees west. South, 33 degrees west. Yeah. How far is the first ranger from the fire? Okay. It's worth it for me and for you to take a couple minutes to really try to draw this in, because that's the battle. Can you draw out this? That's what's hard. So let me give you a minute to try it. So I'll jump in a little bit. So we've got the first ranger. And where's the fire from him?
South.
Directly south, huh? Directly south. So just straight down. You good? Right? You good with the directions, right? North, south, east, and west. So south, just directly straight down. Here's the fire. Good so far? So Ranger 1, fire directly south, right below him. I don't know how far below, but it's not off to the right a little bit or the left a little bit, is what I'm saying. It's straight, is what they're saying. It's straight south. Okay, now, second ranger, where's he? 6 miles east. So that's straight east, or they would say otherwise, right? So that's just straight to the east. Here, I'll be able to just make it, I don't know how far, I'm just going to draw it. Boom. There we go. 6 miles to the east, there's the second ranger. We good there? So far, so good? So the fire is directly south of the first ranger, and the second ranger is directly east. 6. I put a 6 up there. 6 miles. Now, let's do the bearing information thing. This. Can you put that on there? So let me encourage you. Whenever they give you bearing information, make a little axis system right there. North, south, east, and west. That's a lot of what you want to do. Just make a little axis, a little compass axis system right there, and then draw out the what they're saying. South 33 degrees west. Okay, so it says, remember, whatever comes first you start with. South. First comes the south. So south, but not straight south. 33 west from the south. Right? You start, it's like Austin was asking, you start with the south, and then from that, come off of that 33 degrees. So that's the bearing to, and by the way, that's what we're talking about, the bearing to the fire. I probably should have started with that. We're saying this is 33 degrees. The bearing to the fire. Yeah, I'm sorry, I probably did that backwards. You should have started by drawing a line directly from the second ranger to the fire, because that's what we're talking about, right? He sees the bearing from the second ranger to the fire. So that's what we're talking about. We're talking about the line, the bearing, the heading from the second ranger straight to the fire. That's what it means by your heading or your bearing, right? From the second ranger straight to the fire is south, but not straight south, 33 degrees west, towards the west, from south. Good? That's our picture. And what do they want me to find? How far first ranger is from the fire, which is over here, call it X. They want me to find that, don't they? So right triangle, because that's, how do you know? Because that's straight south and that was straight east, they told us. So that is a right triangle, which is great because we need a right triangle to use our SOHCAHTOA stuff. So I bet you can all get it from there quite easy, right? But what would be let me just do the first step. What would be our first step? Yeah, this one, huh? So 90 minus 33, what is that? 57, so this one's 57. And then what trig relationship would involve the x and the 6? Tangent again, opposite, back to tangent, adjacent. So tan of 57 is x over 6, and you can do the rest blindfolded, I'm sure. So, right, so everybody okay with that picture? Questions? Let's go ... Questions on that picture? That's the hard part, huh? Is reading those and writing that picture. Make sense how I walked through it? So whenever I think the directly south, directly east, that's pretty good. The last part, let me say it one more time. You want to draw a line when they say bearing from the second ranger to the fire. You want to draw a line straight from the second ranger to the fire. And then when they say the south, 33 degree west, draw an axis system. So south, 33 west. Let's try number 15. You leave your house and run 6 miles due west, followed by 4.5 miles due means straight, right? Due west, followed by 4.5 miles due north. At that time, what's your bearing from your house? Okay. We got 3 minutes. I can get. So this is your house. You just want to put the house in the center, or the starting point in the center. 6 miles due west. So this is west, east, north, south. So 6 miles this way, and 4.5 that way, huh? So here's where we end up. That makes sense? So we went 6 miles due west, and we went 4.5 miles due north. Right? West and north. And they say at that time, what is your bearing from your house? Meaning from your house to this point, what is the bearing? So what am I going to do? Well, I'm going to do it quick because we've only got 2 minutes left here. Bearing is this angle. Remember? Because bearing is always off of the north or the south. Everybody catch that with the way we do bearing? They could have made it up where you start east-west. They totally could have. They just decided that with bearing statements, we'll always start with north or south. So if you're going to start with north, then you need to know the angle off of north. So to find that, I first have to find the angle in here, and then because I got to start with one of them in my triangle. And then once I get that, I'll subtract from 90 and get the one I need. So how do I get this angle in here? SOHCAHTOA, I'm in the right triangle. SOHCAHTOA, it's tangent again, isn't it? So call this one theta. Tangent of theta is opposite over adjacent. 4.5 over 6. How am I going to find theta there? What am I going to do? Tangent of theta, tan inverse. So this is that one we did, number 3. The way to get a tan out there is tan inverse. Everybody see that? Tan inverse, so cancel tan. Right, because you got to get that tan off of there, huh? Everybody see that? So then we go tan inverse. And I'm getting 36.87 degrees. And then the angle itself that we're looking for is 90 minus that. So the angle itself is, bless you, 53.13. So we'll just say 53. I should round to the nearest whole angle. 53. So it's north 53 west. North 53 west. It's that one. Everybody see that?